Hey everyone, welcome to our workshop today on how to build Agentic RAG. We're going to get started in a few minutes here. At the beginning, I'm just going to let these slides run while we let people into the room. So over the next few minutes, we'll get started at 9:02 with the presentation. But for now, we're just going to let these slides run. We're going to let people trickle in, and then we're going to start working on how to build Agentic RAG. Okay, the time is now 9:01, so we'll let people come in for another minute or so, and then after that, we are going to get started with our presentation, and we're going to go live. While you're trickling in, it'd be great to know where you're coming from, so if you can hear me, just let me know. I'd love to know where people are coming from. Most of the time, it's Seattle or SF or New York. Sometimes we get some people from different locations like Utah or New Mexico or Miami, but often it's Seattle and New York. Oh, and we have some people from Munich. Ah, yes, Thomas, I remember you from last time. Andre, yes, I remember you as well. Seattle, that's great. Santa Clara, okay. The Bay Area. I kind of grouped the Bay Area entirely into SF, which really isn't fair for everyone else, but that's pretty much where I go when I go visit the Bay. Okay, so the time is now 9:02. I'm going to start our presentation. So let's see. All right, so today we're going to be talking about agentic RAG, or basically, how do you build RAG with AI agents? And the main thing about this is that we're going to cover RAG. Oh, wait, I'll go to the next slide. We're going to cover RAG, and then we're going to do a brief talk about AI agents. It's going to be super brief. We're just going to talk about what AI agents are. And then we're going to talk about how that kind of affects RAG. And then we're going to go directly into our workshop. Okay, so we do have someone who is coming directly from SF, which is the city that I'm most familiar with in the Bay. All right, so let's start with our RAG review. So most of you who have been here before have, you already know what RAG is. If you've been paying attention to the AI scene, you already know what RAG is, right? Give your LLM access to your data. That's the whole idea behind it. LLMs don't have access to your private data, so they need context, and that's how RAG works. So a tech stack for RAG would be using some sort of LLM, some sort of vector database or vector search engine, some sort of embedding model, and some sort of frameworks, which are optional because you can really do these yourself. You can just build your own frameworks. But in this example, we're going to be using some of these frameworks. So this is my small RAG, basic RAG kind of pipeline. So basically you'll have your data, you put it into an embeddings model. That embeddings model puts that data into a vector database. And then at query time, your query is going to go to the LLM. The LLM is going to search the embedding model, and then it's going to go to the vector database to get the closest vector. Or sorry, the LLM is going to send your text to an embedding model. It's going to take that embedding, it's going to send that to the vector database, and then it's going to send the most similar responses back to the LLM, and then the LLM is going to send that back to you so that you can get the answer to your query. Oh, great. We have someone from New York as well. This is always the big location. Seattle, SF, New York, all covered today. So we're going to cover briefly what some of these technologies are, right? The LLM, the vector search engine, the embedding model, and we're actually not going to cover any frameworks. So the LLM, right? So LLMs are basically, they have been around since probably, depending on what you consider large, since about 2022, really popular. GPT-3 came out, ChatGPT came out, and this is a decoder-only architecture, right? So this is a build off of the transformer model, which came out in 2018. And the transformer model was built to solve the context problem that RNNs have. And RNNs were built to allow you to do sequencing, which originally deep neural networks did not let you do. So now we've arrived to the point where we're building with mostly decoder-only architectures. An example of an encoder-only architecture would be like BERT, if you've heard of that, B-E-R-T. So this is the architecture for GPT-3, and this is what most LLMs kind of are inspired by. So the other part of this, RAG stack is vector search. So if you've been following me for a while, you've heard me talk about vector search probably at least 100 times now, but we're going to talk about it again. So vector search is the ability to compare unstructured data in a quantified manner by modeling that data as a set of numbers, as a list of numbers, or a vector embedding. And in this example here, we see that vector search shows you this similarity kind of embedding, right? So here in this top right corner, we have houses, puppy, dog, and cat. And you'll see that puppy and dog are close, and they're closer than dog and cat and puppy and cat. And then away from all of these is houses. So the idea here is that these words that are closer in meaning are closer together when you're performing vector search. And the way you get these vectors is you run them through some sort of embedding model. Typically you use text, but if you were here last week, you know that we can also do this with images, and we can use multimodal models like CLIP to do both image and text data. So in an embedding model, we run text through an embedding model and we get a set of numbers, which we call a vector embedding, which allows us to quantify and compare in a quantifiable manner unstructured data. So in the workshop, what we're using is, this is the slide from last week. I forgot to change this. So OpenAI for LLMs, Face for the vector search. This time we're just going to be using the OpenAI embeddings. So last time we used CLIP because CLIP is multimodal and allows you to work with images. This time we're just going to use the regular OpenAI embeddings, although you can just switch out the embeddings model however you would like. We're going to be using LangChain for orchestration, and we're going to be using Arise Phoenix for evals. So this is what our tech stack looks like. You can take that OpenAI thing that's on top of the LLM here, and you can move that down here, and you'll get the same thing. But typically what we normally do is we get our embeddings models from Hugging Face, and I'll show you where you can change that in the code later. So in this workshop, what we're going to be doing is we're going to be taking the data, running it to an embedding model, putting it into Face, sending that data to OpenAI through Face, and we're going to be using LangChain to orchestrate all of this, and then we're going to be sending that data back into the query. Okay, so this is the review of RAG. I'm going to just stop here for a minute, and if any of you have any questions about the RAG review before we move on to anything about AI agents, please drop that in the chat, and we'll cover that. And we'll cover any questions before we move on. Someone says the face equals Hugging Face. Yes, that is the Hugging Face logo. That's the emoji, the Hugging Face emoji, and it's also the Hugging Face logo. Okay, it doesn't. Oh, no, face. Oh, F-A-I-S-S. No, yes. Okay, yes. So I should cover what that is. So face, F-A-I-S-S, is different than face, F-A-C-E, Hugging Face. So F-A-I-S-S is Facebook AI similarity search. And it's a vector search algorithm developed by Meta, I guess. Now Meta, formerly Facebook. That's why it's called Face and not Mace. So that's what Face is. It is a similarity search algorithm that allows you to compare vector embeddings. Last time, or maybe not last time, but one time someone asked about the production readiness of Face. And so Face is actually what all of the, vector databases that are like popular vector databases, they're built off of Face. Now they're built off of other things as well. They have a lot of other things in them, but Face is what they use to build part of their vector search algorithms. I see someone's also from Houston, Texas. That's an interesting tagline, the world's energy capital. Grant asks if this will be recorded. It will be recorded. You can come back and visit this link at any time, and you will get a recording of this workshop. I will also be sending out an email to all of the people who have registered on the Luma. If you haven't registered on the Luma, I'll drop a comment in the LinkedIn post so that you can register on the Luma and you can get the email. There will also be a certificate available to people who have completed the workshop and actually built the code, the project that will be shown later. And if you get that certificate, you can also share that with us on LinkedIn, and we'll help you share that with our audiences as well. Okay, so I don't see any more questions on RAG, so we're going to move on to AI agents. This time I've got one simple slide about AI agents that we're going to talk about for a couple minutes here. So the idea behind AI agents is that you can let AI autonomously execute your workflows, right? So if you guys remember, like back, I don't know, not that long ago, there were like things like if this, then that, or Zapier, these kinds of things. And what they do is they allow you to put some things together and execute some workflows. What that's really doing is that's just like, routing some apps and routing some function calling, some APIs. And that's like the precursor to AI agents, right? That's essentially what these AI agents are doing. What they're doing is they're looking at these API calls. They're getting some sort of natural language instruction, and we'll see the instruction they get later. But they're getting some sort of instruction on how to call these different tools, and they're using these tools to build some sort of workflow, okay? So AI agents are a kind of like a combination of things like Zapier or IFTTT, if this, then that, IFTTT and LLMs. So these are a relatively new innovation because LLMs have unlocked this ability to do something that seems like reasoning. Now, I'm not going to go into like the philosophical understanding of whether or not these LLMs are reasoning and have consciousness, but in general, LLMs can do something that seems like reasoning, and they can do it well enough that they can autonomously execute workflows when you give them the correct instructions, right? And so if you've seen this term called function calling, you'll know what I'm talking about, because function calling is basically the way that these LLMs do this kind of autonomous workflow execution, okay? So function calling is what people are calling the ability of LLMs, the ability to build AI agents out of LLMs. And actually tomorrow, if you've been following me, you've seen that I'm hosting this big mid-year Gen AI Zoo tomorrow. So that will include a talk from someone from Fireworks AI who will tell us more about this ability of function calling, because they just released function calling support natively on their LLMs. And basically putting all of this together, putting all of the RAG we just covered together, along with this ability to do function calling, we can build an AI agent that does RAG, or we can build what people are calling agentic RAG, using function calling to call functions that will perform RAG, so that we can use AI agents that will do this retrieval augmented generation work for us. So we no longer need to build the workflow as we showed in the slides earlier. We don't need to build this exact workflow. What we can actually do is we can give the AI agent access to face, and then this workflow will be built for us using the AI agent. So that's what it means for the AI to autonomously execute a workflow. It's not just going to you don't have to put things together manually anymore. It's going to automatically do it for you. Okay, I'm going to pause here to see if there's any questions about AI agents, and I'm also going to bring this back to the stage. If you are if you're looking to learn more about generative AI, tomorrow we have a huge summit where we're going to have 12 different speakers from 12 different companies coming to talk to us about generative AI and generative AI innovation, including someone who's going to be coming to talk to us about agentic RAG. I'm going to leave this up here for a minute. I hope to see you guys there tomorrow as well. But during this minute, if you have any questions about AI agents specifically or about Agentic RAG, drop them in the comments and I'll address them now. Love this comment. Looking forward to tomorrow's zoo. I am as well. Okay, so I think it's been about 45 seconds, maybe a minute. I don't know. Actually, no, I'm not great at judging these like random passages of time. Anyway, we're going to go back to this slide. I'm going to pull up the code. Okay, where is the code? Here it is. All right, so let's zoom in. So let's put this in, and then let's zoom in a little bit here, and get rid of this, and get rid of all of these things. Okay. So, oh, someone has asked a question. I should have waited longer than a minute. How are we controlling structured outputs from the LLMs that will be used in the function calls? They'll be used in the function call. So okay. Let me think about how I think this question seems to be based on an understanding of how the function calling will happen. The LLM output will not determine the function calls. Theoretically, and mostly in practice, of course, LLMs are hallucinatory in nature, and not everything is 100% controlled. But like theoretically, it's your input that matters for what the LLM will do. So if you give and we'll take a look at this later, but you give the LLM some sort of input, and it will use that input to determine whether or not it needs to call a function. And then that is how it calls a function. And then in terms of structured outputs, I'm sure you've seen a lot of things, a lot of posts around structured outputs, but like all you need to structure the outputs for this use case is you need to turn it into a string, and that's pretty much it. Now, there are some use cases where you want to do structured outputs that turns into a JSON or something like that, and that's going to be a slightly different use case. That's going to be a slightly different challenge, problem, maybe, whatever you want to call it. That's going to be something that's going to be slightly different from what we're doing here. But also, that's not really needed for the function calling, not always. So maybe this will make more sense when we go through the code. But essentially, the function provides when you create the function, you provide some instruction on how to call that function to the LLM, and then based on the LLM's other inputs, it's going to decide whether or not it needs to call that function. Could you clarify the last comment you made about how the LLM does routing? I've had success providing few shot examples and getting the LLM to route on that. Were you suggesting doing routing based on retrieved content as well? Routing. I assume that this is talking about routing like the information around in terms of like, hey, like we're routing from the vector database to the LLM. So there's a couple of different. So I actually built a different agentic RAG application, and maybe if we have time, we can go into that later. That does route in terms of like it uses different vector databases to route different things. So that's a good thing to keep in mind. That's not what I had planned for this, but if we have time, we can go into that later, and I can show you how that works. or maybe I'll just do something on that next month. But I don't think you need to route based on any suggested retrieved content, but you can route based on like what the instructions tell the LLM the function does. NL to function call or to a specialized agent. I don't know what NL means actually. But also specialized agent. In this application, we're not going to be using an agent to call other agents. I have heard of this idea. People are calling this a swarm. Some people are pushing the idea of more agents is all you need, scale of your number of agents, et cetera, et cetera, et cetera. I don't know about that. Routing, natural language. Oh, yeah. Oh, that totally makes sense. Right. Yeah. Natural language call to a function or a specialized agent. No, we don't need the retrieve data to do that then. No, then that's an easy answer. Okay, but I have heard of this thing called swarms. I have my doubts. We'll see how that plays out. Maybe they will go really well, and I'm going to look back on this in like 6 months to a year and be like, damn, that was dumb. But I have my doubts about that. Okay, so let's get into the code. I will stop in the code to answer questions as well. So don't worry if you have other questions, just drop them in the comments and I will answer questions as we go. So the first thing we're doing here is we're just going to install a bunch of libraries. So LangChain, LangChain Community, LangChain got to LangChain Hub, LangChain OpenAI, right? So LangChain got really, really big. And we also, I don't know if I included this here, LangChain text splitters also needs to be splitters. Okay. So all of these are just different tools in LangChain that you need to use to basically to orchestrate this kind of work. So if you guys remember back in 23, LangChain was kind of small, but they had a ton of integrations, and now they got really big, and now you have to have community integrations because it's too big to put into just LangChain. And even then, LangChain core is huge. So I suggest you run this package like while I'm talking because it's still a huge install, okay? So you've got LangChain, you've got LangChain Community, you've got LangChain Hub. So LangChain Hub you don't necessarily need, but I'm using it this time so we can show you what Harrison Chase's suggestions are for how to build a RAG application in terms of giving it instructions. LangChain OpenAI, it's to access OpenAI with LangChain. LangChain text splitters, that's the text split. Okay, here's the non-LangChain installs we're using. So we need face CPU. And so if you're using Hugging Face, you'll need sentence transformers as well. But here we're just using face and, yes. So if you're using another vector database, you'll need to install that as well. But here we're just going to use face and we're going to use a CPU option because I don't have a GPU ready. And also GPUs are scarce. And then we're going to be using Arise Phoenix Eval. So this will be showing us the routing that we do. This will show us how the agent made the calls and what calls the agent makes. So at the end, we'll look into this UI later, and it's going to be in like a window. It's going to be in like a Chrome window, and we'll look into this UI later. But this will show us how the agent made its calls, and it will allow us to see what's actually going on behind the scenes. Okay, so won't swarms be expensive? So here's a question. Yes, swarms will be expensive. Because generative AI is expensive. Where is the code? Oh, that's a good question. You know, I forgot to push this to Git, so let's do that. Great. So now that this is on GitHub, I will send it out. So let me get to that. So if you are subscribed to the Luma, you will get a post momentarily. Send a post. Code is here. Thank you for asking. Okay. So that's where the code is, and I'll post it on LinkedIn as well. So here, that's where you can find the code. And if you are not, you should subscribe to the Luma event as well, so you can get follow-up information, as well as the chance to get a certificate. Okay, so that's where you can pull the code. You can also alternatively try to follow along as I run through this code. I will try to make sure that you have the time to, type this out. It is kind of long, but basically what we're doing in this first line here is we're just getting this directory loader from the LangChain community's document loaders. And essentially what this does is this allows us to load in a whole directory. As you see here, we have a directory of city data. This is data that I scraped from Wikipedia. So we'll be asking questions about some of these cities. And then we're going to get the recursive character text splitter. So someone has asked about this before. There's a recursive character text splitter and there's a character text splitter. These are just different ways that you can split text. Oh, can I go into this code here? Oh, okay. Sometimes you can like command click into it, but I guess I can't command click into that specific one. Let me see if I can do it down here. Okay, it's not going to let me do that right now. I don't really know how that works in VS Code. Sometimes it does let you do it. Sometimes it doesn't. Really weird. But this is just a different way to check your text splitters. So text splitters, there are character text splitters. There are multiple. What you can do is you can specify characters that you want to split your documents on. If you care to learn more about this chunking, chunk overlap, splitting stuff, I've got another workshop on improving RAG that's coming up in 3 weeks, and it also ran 2 weeks ago. So if you want to just loop through that, you can take a look. But it's just a way to split different text. In the next slide, in the next cell, all we're doing is just loading up our environment variables and loading up our OpenAI API key. Really, as far as I know, like I do this explicitly, but as far as I know, as long as you have your OpenAI key in like a .env file like this, which I'm not going to show you, you should be able to. You probably don't even need this. If you have other API keys, you'll have to do this explicitly. But as far as I know, LangChain actually does this for you now. And then we're just going to launch Phoenix as an app. This is just how you launch Phoenix. This is the way that you're able to see the traces of the of the API calls that you made. And so what we're going to do is we're going to launch it as an app, and then we're going to call the LangChain instrumenter. So LangChain instrumenter is just Phoenix's way of instrumenting on LangChain. Instruments on LangChain are like, what are they? Like just like different tools in a sense. And so this allows Phoenix to know that it should be looking for LangChain like calls. Okay, let's see. Someone says an open source swarm isn't expensive. Using Grok's API, using Llama 370B or many local APIs for specific tasks are low to no cost. Okay, well, clearly someone believes that open source swarms are not expensive. If you have your own GPUs, you can run them locally for free, of course, for the cost of whatever it costs to run those GPUs. So there you go. Or if you have Grok, G-R-O-Q, apparently their API is low cost as well. I haven't actually tried this. I've tried running some swarms, but haven't gotten great results from that yet. If you do have good results, Jeannie, you should drop some of those in the chat and let people know about those results or ways to do this, because I think that would be very interesting for a lot of people to see. Okay, so the next part here, we're essentially just splitting up the text. So we're creating a text splitter. We're identifying a chunk size and a chunk overlap. All this is a way to make your data into processable chunks. And then we're going to load up our city data, and we're going to load it, and we're going to split it using the text splitter. So this should take a few seconds, less than 10 seconds, probably about 4 to 5. 5, okay. And then the next thing we're going to do is we're going to go and we're going to put this into Face. So in many if you're going to use a vector database without LangChain, if you're going to use a vector database just straight up, you're going to want to identify the dimensions of your embeddings, and you're going to want to embed things before you put them into the database. Because LangChain provides this like nice wrapper that allows you to call this thing called a from documents. From documents, you just pass it the embeddings function, and it will embed everything and put it into the docs for you. But just for everyone's reference, OpenAI embeddings are 1536 dimensions. A lot of other embeddings are smaller dimensions, like Hugging Face has a lot of smaller dimension embeddings. It just really depends on what you need, right? Higher dimensions is going to be more expensive, but it's going to be more fine-grained. So you're going to be able to do more granular kind of things. Of course, everything does depend on the data that your embedding models are trained on. So for example, if you have embedding models that are trained on images, then you should use that on images like we did with Clip last time. Other embeddings that might be important would be like domain-specific embeddings. So like if you have like horses and, cars, like then you've got Bronco and Mustang, which could be either a car or a horse. And you've got Pony, which is definitely a horse. And you've got like Ferrari, which is definitely a car, right? So that's just something to keep in mind with your embeddings. And this is how you put your embeddings into Face. And now the next step, what we're going to do is we're just going to make a retriever tool. So this is the LangChain functionality to turn your vector database into a retriever, right? So let's see if I can click into this. It's not letting me click in. Okay. Vector databases like Face or vector stores or vector search engines, whatever you want to really call them, are just a way that you can search vectors, that you can compare and search vectors. But they don't automatically do that. You have to kind of pass some values in. So the way you make it easier is LangChain provides this way to retrieve these tools using something called a as retriever type functionality. So once you have these in retriever, what you're going to do is you're going to create a tool, right? So I have an example using Llama Index that uses multiple tools that maybe we'll look at next time, or if we have time later on, we'll take a look at that today. But for now, what you really need to know about this is how do we create this specific type of tool? So there's many ways you can create tools, and LangChain provides a way to create a specific type of tool called a retriever tool. And so in this case, you just call create retriever tool, and you pass it the retriever. You pass it the title of the tool. So this is what the tool is called. It's called Search Cities. And then you give it some instructions that tell it what to do, or what this tool does. Searches and returns excerpts from Wikipedia entries of many cities, right? And so this is for passing it on later. But this is what the tool, this is how you create a tool. This is how you create a retriever tool. There are more than just retriever tools in LangChain. It has many different types of tools. But one of the ways you can create tools is using this thing to create retriever tools. Okay. So from there, what we're going to do is we're going to actually pull the prompt messages from Harrison's LangChain OpenAI Tools Agent Hub. So LangChain Hub is just a way that you can store a bunch of different types of messages. And in this case, we've pulled these messages from the hub, and we're using Harrison's template. So I think this is pretty interesting stuff. So let's take a look at this. I'm going to open this up in a Markdown, and we'll take a look at what this looks like, right? So apparently, we're giving a system message prompt. So this is a template that allows you to provide messages directly to the system, to OpenAI. And here we're creating a prompt template, and all the prompt template is saying is, you are a helpful assistant, which is really all you need, right? So there's been some papers on the conciseness of your prompts and how that's helpful. There's been some papers around how you can add this, but really all you need to tell it is that it's a helpful assistant. And if you need to specify this further, for example, if you're working in a specific field like healthcare or whatever, then you can say you're a specific helpful assistant with expertise in healthcare, something like that. And then we need to give it some sort of way to hold on to some of the messages that are going to come when it does its, let's say, rationality thinking. So we just call it chat history, and we say it's optional because you don't necessarily need this. And then we give it a way to give input. So this is how we give messages. This is how we prompt the This is how we prompt the LLM, is we give it some sort of human message prompt template, and we give it an input variable. And all we're saying here is we're just going to directly pass in this input. And then we're going to have another thing called an agent scratchpad. So this is important because the agent needs to think. And so it needs some sort of scratchpad to think. Okay, so that's all that's going on here. Actually, I don't need this. Okay. And then we're just going to get the LLM. So we're using a temperature of 0. So our LLM, doesn't exercise any extra creativity. We don't really want an LLM that's going to be very creative when we're doing RAG. We want an LLM that's going to be like, hey, we're going to, it's going to work as expected. Okay, so now we're calling the agent executor and the tools agent, a way to create tools agents. So the create OpenAI tools agent function, what this does is that this takes an OpenAI model, and then it passes some tools and a prompt. So, right, we got the prompt here earlier. We made the tools earlier here. And now we're passing these to, that's not right. We're passing these to the LLM so that it knows that this is an agent that can use tools that's using OpenAI. And this is very specific. This is an OpenAI tools agent, right? So this doesn't work for every model, but it does work for OpenAI. And it works for things that are also OpenAI aligned. The next thing we want to look at is this agent executor. So what this does is this basically, you give it the agent, you give it the tools. So here's the agent. It knows that it has these tools. And this executor says that you can use these tools, and this allows you to execute the agent. Really sounds kind of like, like if you watch like James Bond movies, like agents get executed, but not in this manner. We're not killing the agent. We're just we're running the agent. Anyway, I think it's a weird naming convention, but we can run the agent, and then we can get the output. So if we ask, how big is Boston? We'll get the output. Oh, we don't need this part. We'll do this part later. Boston has an area of 48.4 square miles and a population of 675,000 as of 2020. Is the third largest city in the Northeast after New York City and Philadelphia. Okay, so here comes the interactive portion where you can give me some questions about these different cities, and we'll ask you some questions, and then we'll look at the traces later. So another question we can ask is like, what are good landmarks to visit in Karachi? Is that how you spell it? How you spell it? Karachi. Karachi, yes. Some of the good landmarks to visit in Karachi include Aga Khan University Hospital, Grand Jamia Mosque. I can't pronounce any of these, so I'm going to ask you something else. What is an important historical fact about, what are some, let's ask for some. What are some important historical facts about Paris? Paris for you Europeans. Although there isn't anyone from Europe. Oh, no, there is. There's someone from Munich. So Paris for you. Paris has a rich history dating back to its origin before the Middle Ages. The city was composed of several islands and sandbanks and a bend of the Seine with 2 islands. I'm not going to pronounce these. In the late 12th century, Philip Augustus extended the Louvre fortress, built the city's first walls, rebuilt bridges, and paved main thoroughfares. Okay, so this is a lot of information about Paris. But we'll take a look at this later, and we'll see some more information about this. Oh, someone said update, but I don't see any update. I don't see any other questions for the agent coming in. Are there any other questions for the agent? I'll pause here just to let you guys ask some questions. If you guys don't have any questions for the agent, I'm going to ask it a couple more questions, and then we're going to review the trace. And then we'll just open up the forum for questions. And if there are questions, we'll answer some questions. Otherwise, we will just call it a day. And I'll send out all of the post-event info afterwards. Okay, let's ask it. Let's ask it. How big? How old is London? For nearly 2 millennia. Is that true? Oh yeah, the Romans. Okay, as Londinium. Interesting. Huh. Okay, I didn't know that. So that was fun. Let's ask it one more question about one of these cities. Can I ask it to compare nightlife in Berlin and Paris? I'm not sure it's going to be able to do that, but we can. I'm not sure that information is available on Wikipedia, but we can ask it. Compare nightlife in Berlin. Or how about this? How is nightlife in Berlin compared to nightlife in Paris? I don't know anything about this, by the way. Like, how is nightlife in Berlin compared to nightlife in Paris? The nightlife in Berlin is known for being diverse, vibrant, and one of the most celebrated in the world. Berlin's club scene is a premier nightlife venue with historic buildings in somewhere being occupied by young squatters and transformed into underground and counterculture gathering spots. The city is home to many nightclubs like Watergate, Tresor, Berghain, and Kit Kat Club, known for sexually uninhibited parties. Clubs in Berlin do not have fixed closing times, blah, blah, blah. Okay, where's Paris? Berlin, Berlin, Berlin. Is it telling me anything about Paris? Paris has a rich history of jazz clubs in this place and this place, introducing Parisians to renowned musicians. The city hosts yearly festivals like the Paris Jazz Festival and Rock en Seine. Paris is known for its brasseries that serve food and drink. And I hope I'm not like pronouncing these like terribly wrong. Okay, so it's overall Berlin's nightlife is characterized by underground diverse club scene, while Paris offers a mix of jazz clubs, festivals, and traditional brasseries for a unique nightlife experience. So the person who asks, if you've been to Berlin and you've been to Paris, let me know if this is true. What is the most beautiful city for modern architecture? Once again, I'm not sure it's going to be able to answer this, but which of the cities have the most beautiful modern architecture? The search results do not provide specific information on the most beautiful architecture in cities. So there you go. It isn't able to answer this, which actually it shouldn't do. If it does not provide, if the context does not provide information on this, then the LLM or the AI agent or the RAG system, whatever you want to call it, should not answer this question. It should tell you that I don't know. And that's exactly what it's telling you here. And it's even prompting to ask about specific city or any more details about this kind of like modern architecture. So this is actually a really great example. Thank you for asking that question. This shows that this LLM is even, this system, this AI agent system is even able to self-regulate and provide guardrails in that manner. Okay, so I think we've kind of gone through a good amount of whatchamacallit. All right, let me see if I can find where I have the let me see if I can find where I have the here it is. Here's the traces. So somebody just asked something about like would love to see the documents retrieved for these questions. Well, ask and you shall receive. Where did I just put this screen? Huh? I literally just saw the screen and now, here it is. Okay. So let's see. Let's see what it's saying. It's not getting anything because it can't find the documents. Search cities, retriever. Oh, it is. It's finding documents. It says modernist architecture. That's Munich, Moscow, Paris, and Berlin. And it says here are some of the things. So it's getting 4 documents, by the way. It's the person who asked how many documents it's getting. And it's clearly finding that despite it's getting these documents, it's not getting specific results on the most beautiful modern architecture. But also, that's a very subjective question. Like, That's like asking your friend like what the most beautiful architecture. I mean, I guess that's how people think of these AI agents, but these systems are really only able to answer objective questions. Like beauty is a subjective experience, and asking an AI what the most beautiful thing is only going to get you like an aggregation of some opinions. And it's not even going to get you like aggregation of opinions from experts, which you may or may not value, because who knows how good expert opinion on beauty really is, because everybody's opinion on beauty is a little bit different. So that's a very subjective question. I'm not surprised the LM didn't answer it. I'm glad it didn't answer it. Anyway, how is nightlife in Berlin compared to Paris? So let's see what it found for this. So here's the steps here. Here's what's happening. So basically it's saying this is the runnable assistant. We're going to go to the scratch pad. We're going to call these things. Here's the template that we need. Here's the metadata about this template. Okay, here's what's being sent. Nightlife in Berlin, nightlife in Paris. So it understands that you need to call both of the functions. And then it's saying, okay, here's the input and output. This is annoying to read. So it's calling search cities. And so in this one, nightlife in Berlin. And it's saying, hey, here's these texts from Berlin that talk about nightlife, Berlin nightlife, parties, numerous cafes. This is not about nightlife. Berlin Wall, also not really about nightlife, but it includes this blurb about nightlife and festivals. So this actually shows us that we should be adjusting the characters text splitter and using maybe the 3 equal signs as text splitters inside of our current model. We should adjust the text splitter. Once again, this is the same thing, but about Paris. So immediately after the war, Saint-Germain-des-Prés, I don't know if that's correct. And Saint Michael, Saint Michael, Saint Michel, I don't know. Somebody tell me how I should be pronouncing this. These names are all very hard for me to pronounce. And then, okay, this is talking about Copenhagen, so this has nothing to do with Paris. But as you can see, it's getting 4 results back, and it's talking about a lot of these results are in Paris, comparing nightlife and cafes and other things like that. Several yearly festivals take place in Paris. And then it's going back and it's taking all of these and it's putting them into the runnable sequence. And it's comparing all of these and being able to compare them. And it's sending it to the chat prompt sequence, the LM, the parser. And this is what it actually ends up returning. Blech. So this is basically how you build an AI agent. So yes, how many documents does Retrieval pull? It pulls 4. So this is how you build an agentic RAG system. We've got a few minutes left here. I do have to duck out at 10, but if anybody has any questions, I can stay for the next few minutes and we can answer some questions, or we can ask the AI some more questions and play around with that. Otherwise, yeah, just let me know if there's any more questions. Oh, someone says, took a second, but here's a couple of personal examples running jobs with NATs and AWS EC2s using instances with local models. GitHub.com/Yerbimadi. I don't know. Nat's email. Okay, so I'm going to pause here for a minute or two and just see if there's any questions coming in, and we'll answer those questions as they come in. Great. So I see people saying thank you, which means, I assume means that there are not any questions from you guys at this moment. So if you would like to get a certificate, I'm going to send this forms here. I will send this out again to everybody who's registered on the Luma page. And yes, so once you build this example, play around with it a little bit, send me the GitHub repo. I will get you a certificate from OSS for AI as well as Arise. It looks like that's it for today. So I'm glad you guys all came, and I will see you guys around. Feel free to reach out to me and ask questions as you would like. I hope to see everyone tomorrow at the mid-year Gen AI Zoo as well. All right. Peace.